Welcome back. This is video 2 from lesson 4.3. So if you haven't watched video number 1, really should go back and watch video number 1. We're going to talk about the zero product property. If the product of two expressions is 0, then one or both of the expressions equals 0. If A and B are expressions and A times B equals 0, then either A has to equal 0 or B has to equal 0, or they could both equal 0. So, for example, if x plus 5 times x plus 2 equals 0, then x plus 5 equals 0, or x plus 2 equals 0. And if you solve both of those little baby equations, you get x equals -5 or x equals -2. So what we're going to be doing is we're going to be taking trinomials. We're going to factor them into a form similar to x plus 5 times x plus 2. And as long as they equal 0, we can solve. So that's one thing that's really important is this is the zero product property. You can't use it with any other number on the other side of the equation. So what will you do? You'll make sure everything's on one side of the equation and that it's set equal to 0 before you factor. The solutions of a quadratic equation are called the roots of the equation. And so that's going to be important because sometimes you're going to be asked for the roots. And that just means find the solutions. Okay, so what are the roots, solutions, of the equation x squared minus 5x minus 36 equals 0? So we need a factor. So we need numbers that multiply to be -36 and add to be -5. You can go ahead and make a table if you need to, because they're multiplying to be something negative there. One's going to be positive, one's going to be negative. And so let's see, they're going to add to be -5. So I think -9 and +4 will work. And if you look, -9 times 4 is -36. -9x plus 4x equals -5x. If you need to, make one of those little tables and list all your factor pairs for -36 and see which ones add up to be -5. Alright, so now we're going to apply the zero product property. So we're going to do x minus 9 equals 0 or x plus 4 equals 0. So we're going to solve for x. So x could be 9 or x could be -4. You've got options. You've got two solutions there, 9 and -4. So the correct answer is C. Okay, so let's look at an application because it's always kind of good to know. All right, well, I have to know this for Algebra 2. And guys, all this being able to factor and all, you need to know for pre-calc, for calculus, for college algebra, finite math, you're going to have to be able to do this too. So no matter where you go from here, you need to know how to do this. So this is really investment learning. This is the pep talk portion of the video. Investment learning is learning that not only pays off this year, but in the future it's going to pay off. The better you learn it this year, the less work you have to do in the future. So you might as well spend the time. You got to spend the time at some point. Might as well be now where you get the biggest payoff. But I also want you to see where this type of mathematics is useful in the wild, in life. Okay, so let's look at this nature preserve problem. A town has a nature preserve with a rectangular field that measures 600 by 400 meters. The town wants to double the area of the field by adding land as shown. So they're going to add x meters to each dimension. Okay, and they want to double the area. Find the dimensions of the new field. Well, luckily it starts off rectangular, so the original area is just 600 times 400. So when you want to double that, you just take the 600 times 400 and you multiply by 2. So the new area is going to be 2 times 600 times 400. The new length is going to be 600 plus x. The new width is going to be 400 plus x, because if you look back at your picture there, sorry, it's a little blurry. You've got 600 for the longer side, and you're going to add x meters. You've got 400 for the shorter side, and so you have x meters. So we actually have two expressions for the new area. We have the one involving just numbers, 2 times 600 times 400, and then we have the expressions involving the additional number of meters being added to the length and the width. All right, so we want to FOIL the 600 plus x times 400 plus x, so we get 240,000 plus 1,000x plus x squared. In order to use a zero product property, we have to have our quadratic equal to 0. So we're going to write this in standard form. So we're going to have 0 equals, let's go ahead and put the x squared first and then the plus 1,000x. 240,000 minus 480,000 is negative 240,000. So now we want to factor. The factors of negative 240,000 that add to be 1,000 are negative 200 and positive 1,200. If you want to take the time, go ahead and multiply negative 200 times 1,200 is negative 240,000. Negative 200 plus 1,200 equals 1,000, so it works. So now we're going to set each factor equal to 0 using the zero product property. So we have x minus 200 equals 0 or x plus 1,200 equals 0. So we're going to solve for x, and so we get x equals 200 or x equals negative 1,200. Now if we were just solving an equation that was just an algebraic equation, we could use both of these. But let's think about it. We're wanting to add a certain number of meters. We want to make this part bigger. You can't go in and add additional, negative 1,200 meters. That won't work. So we're going to have to reject that one. So we're going to reject the negative value, negative 1,200. The field's length and width should each be increased by 200 meters. The new dimensions should be 800 meters by 600 meters, because 600 plus 200 is 800, 400 plus 200 is 600. All right, zeros of a function. You learned that the x-intercepts of the graph y equals a times x minus p times x minus q are p and q. Because the function's value is 0 when x equals p and when x equals q, the numbers p and q are called zeros of the function because they generate y values of 0. All right, we're going to find the zeros of the function by rewriting the function in intercept form. One way to do that is by factoring. So we've got y equals x squared minus x minus 12. So that coefficient of our linear term is negative 1. So we need values that multiply to be negative 12 and add to be negative 1. If you need to, make yourself a table. We'll get to part B in just a second. But x minus 4 times x plus 3, or x plus 3 times x minus 4, doesn't matter which order you write your factors. That's going to be the correct factorization of y equals x squared minus x minus 12. And so the zeros of the function are negative 3 and 4. And the way we get them is we do x plus 3 equals 0, and that gives us x equals negative 3. X minus 4 equals 0 gives us x equals 4. So negative 3 and 4. So if you want to check, you can grab your graphing calculator and put y equals x squared minus x minus 12 and see that it passes through negative 3 and 4 at the x-axis. All right, let's do the same thing with part B, x squared plus 12x plus 36. So we're going to write the original function. Y equals x squared plus 12x plus 36. We're going to factor. This is actually a perfect squared trinomial. The 36 is 6 squared, and 12 equals 2 times 6 times x, or 2 times x times 6, however you want to write that. And so it's going to be x plus 6 times x plus 6, or x plus 6 squared. You set each of those equal to 0, and you get negative 6 for each one. X plus 6 equals 0 gives you negative 6, and x plus 6 equals 0 gives you another negative 6. Because both factors yield negative 6, it's considered a double zero. And what's cool is you can actually, if you look at the graph, it looks different. It just barely touches. If you look right there, x squared plus 12x plus 36, you can see it doesn't actually cross the x-axis. It just like barely touches it and then turns away. The function is tangential to the x-axis, and so you have this point of tangency there where it just barely touches it and turns away. And so we have a double zero at negative 6. It's really kind of cool. Okay, so guys, thank you so much to McDougall-Littell and our textbook. They actually provide the most of the slides that I use. I do edit them. But anyway, thanks to them. Guys, listen, go ahead and do the problems to try on your own. Come to class ready to go over them, and then we will get you started on the rounds. And come see me ahead of time, though, if you have any big, major burning questions, okay? All right, guys, have a good day. I'll see you later.